Hi everyone, Mrs. Bilo here. In this video, I'm going to be going over notes slides 11 through 20 to talk about the flow of energy and nutrients in an ecosystem. I just want to start off here, which we've kind of already talked about this. So starting with the flow of energy. Energy can come in many forms, such as solar energy, heat, or chemical energy. That would be in something like a molecule of glucose. And energy is going to originate from the sun. And plants or producers use that sun energy, that solar energy, to make glucose, which is a type of chemical energy through cellular respiration, through photosynthesis. And then something like a rabbit, which would be a primary consumer, would eat the plant and get that glucose and do cellular respiration, make ATP so that it can have energy to do things. And then all of these things can die, and the decomposers can decompose. They use those dead things as a source of energy. And then note that along the way, as plants do photosynthesis or cellular respiration as well, as these animals do it, and as decomposers decompose things, some of that energy will be lost as heat along the way. It's not like it's being destroyed. It's just being lost to the environment and not being used again for something else. But note that the energy isn't getting recycled because it's being lost to the environment as heat. And originally it came from the sun. Versus nutrients, these are things like elements. So things like CHO, phosphorus, so carbon, hydrogen, oxygen, phosphorus, and nitrogen are the main ones we're going to focus on. This right here, this is just referring to the soil. Okay, so those elements can be found in the soil, and the producers or the plants, they get their nutrients, especially phosphorus and nitrogen, from the soil. And then those nutrients can be eaten or consumed, those elements, by, the primary consumer, such as the rabbit. And then again, both these things can die and give nutrients to the decomposer. And the important thing about the decomposer is it is going to recycle those nutrients back to the producers. So that's how we recycle those nutrients and those elements. Because again, energy and matter cannot be created or destroyed. Matter is the nutrients and the elements that are getting recycled. And that energy is just being lost to the environment as heat, and it can't be used again for anything else. And again, as energy flows through trophic levels, we lose that some of that as heat. Okay. And again, energy can come in different forms. Sunlight, which is solar energy; chemical, which is going to be in your carbohydrates or your glucose; and then heat, which is just lost to the environment. And so that's also being shown here. So you could see that there is sun, that is solar energy. It goes to the plant, which does photosynthesis. Okay. And then it's making glucose, which is a type of chemical energy that the herbivores can eat and get energy from. And then we're losing heat along the way. Note that plants can also do cellular respiration as well. They're just making their own food for themselves. And then a carnivore, such as this guy, which would be these would be the primary consumers. These would be the secondary consumers, would get the energy from the bunny or the squirrel. And then all of these things can die, giving energy to the decomposers. I'm just going to add, just like that other diagram, I'm going to add in the nutrients as an example. Okay, so the nutrients can follow the same flow as the energy. Note that it's not coming from the sun, though. We don't get nutrients from the sun. It's going to come from the soil. So that's what the decomposers are recycling. So I'm going to actually show an arrow going back to this. So that's how the nutrients flow through this system. And I would definitely use this to help you with your food chain diagram that you're going to make. All right, dead stuff. I'll post the link to this video with this video so you could watch it. It's really interesting. It just, again, shows how important decomposers are in an ecosystem. All right, so how much of that energy is being lost? So as much as, so 90% of it is being used, and that's for the characteristics of life, for doing, things in your body, using the ATP, doing that cellular respiration to maintain all these things, growth, metabolism, homeostasis, etc. And then I'm going to cross that off, okay? And then that means that, so 90% the organism is using, or some of it is being lost as heat. So that means only 10% is left that actually moves up and gets transferred to the next trophic level. So we'll show that in a diagram. Again, we're taking into account usually sometimes it could be one organism, sometimes it could be multiple when we're moving between these levels. So between producer, primary consumer, secondary consumer, etc. So the primary consumers start with 100%, okay? They are making all of that energy that's available. They're getting it from the sun. So they have all of that available to them. So 90% they're going to use for themselves to do things. So only 10% actually gets transferred to the primary consumer. And then 10% of 10%, well, 10 divided by 10 is 1. Because so we're making it go down every single time. So every time we move up, we're dividing by 10. So 1 divided by 10 is 0.1. And then 0.1 divided by 10 is 0.01. So you could see as we're moving up trophic levels, we are losing energy, and it becomes less and less as you get towards the top. And again, this is focusing on the energy component here. We do have the nutrients, which do get recycled, but we're focusing on the energy. So you're going to notice at the top is where we see things that are the smallest, okay? That is where you're going to see your higher level consumers. And that's because a lot of that energy from the bottom, not all of it is making it to the top of that food chain. And so that's why typically in an ecosystem, you will see a lot of producers. You see a lot of plants, okay? You see a lot of primary consumers, so a lot of herbivores, for example. But then you see fewer of those higher level, secondary, tertiary, quaternary consumers, things like your carnivores, your apex predators, because we're losing energy as we move up those levels. And we can look at this in two ways. We can look at this not just by energy, which is what this is. This is an energy pyramid. We can also look at it in terms of mass, so biomass, and in terms of numbers, like how many, okay? So how many of each organism. So a biomass pyramid is literally counting how much, or weight, in kilograms, right, metric, of each thing we have. And typically you're going to have the most producers at the bottom. Same thing here. Usually producers are pretty large in number versus your herbivores, your primary consumers, still pretty big, but not as big as the producers. And then when you get to those higher levels, you tend to see less of those higher level consumers or your apex predators, because we lose energy as we move up these. So less things can be supported at the very top. Okay. So that's what I was explaining. on that side. Now, sometimes it could be inverted. So this is if we have something like an aquatic ecosystem. Now you're like, what the heck? Why are there more carnivores than herbivores? And that's because these producers actually, they are they have a very high turnover. So they're reproducing and dying very quickly. Even though at a snapshot in time, it doesn't seem like there's a lot of them. They are constantly being replaced so they can support these things at those higher levels. Okay. So it might not seem like there's a lot of these or there's a lot of numbers. This is again talking about density of them, or you could look at it in terms of mass. However, these things are constantly being reproduced and recycled. So we constantly are able to supply these things at higher levels. And then sometimes this one is a pyramid of numbers. Maybe it depends how you're looking at it. Like a single tree, for example, can maybe support a lot of other different organisms or even like parasites, for example. So in terms of numbers, there might be one tree versus these ones. There were lots of plants. We're counting each of those individual plants. This is one plant or tree. It can support a lot of things at those higher levels. So again, the shape kind of depends, but typically we're going to focus on these ones where we lose energy as we go up. And that's why we tend to see less higher level consumers at these levels, because there's just less that can be supported. However, we can have some that are a little different or inverted depending on the type of ecosystem you're talking about.